Hi, my name is Emily Mathew, and today I'm going to be discussing a natural treatment for hypercholesterolemia in a zebrafish model. So I first began investigating this topic because there are a lot of people in my family who have been diagnosed with hypercholesterolemia, and so I've seen firsthand the specific medications that they need to take to treat their diagnosis. And also through my research, I found out that 18 million Americans cannot afford to buy their prescribed medications, including the ones that are supposed to help them treat their hypercholesterolemia. And so the objective of this experiment was to find a cost-effective and natural remedy which would help millions of people who need a alternative treatment to use instead of artificial and prescribed medications. And my hypothesis was that tomatoes would be the most effective at lowering high cholesterol because they produce a plant compound called lycopene, and lycopene significantly reduces the amount of LDL cholesterol that is produced in the body. And so I focus on hypercholesterolemia in my experiment, and so I wanted to give a little bit of background on the disease. Hypercholesterolemia is a very serious condition where an individual's cholesterol levels are very high, and this can cause atherosclerosis, which is a big plaque buildup in the arteries. And as you can see in figure 1, this plaque is stored in the side of the arteries, and that is preventing the oxygen-rich blood from fully flowing through the arteries. So the amount of oxygen-rich blood that is able to flow through the arteries into the organs that need it is significantly reduced and narrowed. And because the full amount of oxygen-rich blood is not able to get to the organs that need it, there are very serious consequences when the oxygen-rich blood is not able to be received in full amount or received at all. And so if this oxygen-rich blood is unable to be received in the heart, in the coronary arteries, then the individual suffering from hypercholesterolemia can also suffer from angina, which is also chest pain, and they can also suffer from a heart attack. And if this oxygen-rich blood going to the brain is blocked, then the individual can suffer from a stroke. And if the oxygen-rich blood going to the limbs is blocked, then the individual can also suffer from peripheral artery disease. Those with hypercholesterolemia also have an increased chance of heart disease, a heart attack, and a death as early as 20 years old. And unfortunately, 28.5 million people in the world face this scenario and are affected by hypercholesterolemia. That's 39% of the global population. And so, as I mentioned before, there are many medications that exist to treat hypercholesterolemia and also to prevent individuals from being diagnosed to begin with. But as I also mentioned before, 18 million Americans cannot afford their prescribed medications. So it's very important to find a natural and cost-effective alternative to prescribed medications, especially for diseases like hypercholesterolemia. And one possible promising remedy is tomatoes because, as I said before, they produce the plant compound lycopene, which significantly reduces the low density lipoprotein or bad cholesterol levels in the blood. And when lycopene is introduced into the cholesterol synthesis process, it inhibits various factors, which are all involved in producing LDL and the different kinds of bad cholesterol in the body. So by inhibiting these factors, lycopene is also reducing the amount of high blood cholesterol in total. And in my experiment, zebrafish were used as an experimental model, and this is because zebrafish have very similar lipid-based pathologies as humans, which means that any data that was gathered from the zebrafish trials could also be applied to human health and biology. And so the methodology of this experiment was to have 3 different groups of zebrafish. The first group was a control with a normal diet, so the zebrafish in this group were given their normal food of artemia brine shrimp, and they were given a normal feeding portion. The second group was a control with a high cholesterol, so they were also given the same artemia brine shrimp, except they were given an overfed portion so that they would have high cholesterol. And the third group was an experimental high cholesterol group, so they were fed the same overfed portion of artemia brine shrimp as the second group, but they were also fed the experimental treatment, which was grounded freeze-dried tomatoes. And then the results of the experimental group were compared with the results of the control groups. Now, unfortunately, there were difficulties in sustaining the zebrafish, and inconclusive data was gathered from the experiment, but the results that would have likely happened were predicted, and so I'll just get straight into that. Now, although many different fruits and vegetables have levels of lycopene, tomatoes by far have the highest amount of it compared to any other food. And as you can see in figure 3, lycopene, when it is introduced into the cholesterol synthesis process, the lycopene that is in tomatoes, inhibits 3 very important factors that are involved in producing both cholesterol, low-density lipoproteins, and triglycerides. So the first thing the lycopene inhibits is the LDL receptor, which, as you can tell from the name, takes this LDL in the body and absorbs it into the cholesterol, which raises the high cholesterol levels. So by inhibiting the LDL receptor, lycopene is preventing LDL from raising the high cholesterol levels. And the second thing that lycopene inhibits is the ACAT, also known as the acyl-CoA cholesterol acyltransferase, which prevents cholesterol from being turned into cholesterol esters. And cholesterol esters would then, without inhibition, go on to raise triglyceride levels. And the ACAT also, without inhibition on its own, would synthesize fatty acids, and these fatty acids also go on to raise the cholesterol levels. So by inhibiting the ACAT, lycopene is preventing fatty acids and triglyceride levels from being raised. And the third thing that lycopene inhibits is the HMG coenzyme A reductase. And by inhibiting this enzyme, lycopene is preventing the HMG coenzyme A from being broken down into mevalonate, and mevalonate without inhibition would go on to synthesize cholesterol. So kind of in every aspect, lycopene is inhibiting the cholesterol, particularly the LDL and triglyceride levels in the cholesterol, and is efficiently treating hypercholesterolemia. And so tomatoes seem to be the most effective candidate for lowering high blood cholesterol. They would also be the ideal treatment for those who are suffering from or are at risk of being diagnosed with hypercholesterolemia. And tomatoes are obviously completely natural, easily accessible anywhere in the world, and very affordable for those who believe that medications are too expensive for them to buy. They can't afford the prescribed medications for hypercholesterolemia. So it's very possible that they could use tomatoes as a natural treatment alternative for prescribed medications to treat hypercholesterolemia. In the future, I would obviously like to complete this investigation and gain conclusive data to analyze, but I also think it would be very interesting to look at other natural foods that increase HDL, or the high density lipoprotein, or the good cholesterol levels, rather than decreasing the LDL levels. And so HDL, when it is absorbed in the body, takes that absorbed LDL that was synthesized in the body and it brings it to the liver, which flushes this LDL out of the body. And so it's kind of two different approaches to lowering high cholesterol. The first is seen in lycopene in tomatoes, and this lycopene is inhibiting cholesterol in the cholesterol synthesis process completely. So cholesterol isn't being produced in any way in this cholesterol synthesis process where lycopene is involved. And the other way is with HDL, where cholesterol is still synthesized in the cholesterol synthesis process. And after it is synthesized, it is regulated by the HDL. So the HDL is preventing the cholesterol levels from becoming too high. And so I think it'd be very interesting to compare whether the HDL or the LDL method is more effective, whether increasing HDL or decreasing LDL, and whether one is more effective than the other, or whether they would be more effective if they were combined together, or if there's a different method in which hypercholesterolemia could be treated more effectively. These are some of the references that I used in my experiment. Thank you so much for listening to my project. I hope you have a great day.